Thanks for joining today's webinar. Today, we're going to be talking about the Pinecone vector database and how you can easily build applications to utilize that database. All right, let's talk about the agenda. First, we'll talk about vector databases in general and why they're necessary. Then I'll get into Pinecone Assistant. We'll talk a little bit about the Pinecone Assistant and some use cases, and then we'll use a interesting demo to go through how you get started with Pinecone, and then the QA at the end. All right, so why a vector database? Well, vector databases are important because as the need for data has changed, there's been a paradigm shift. Modern applications now require different types of data. So they're multimodal data that is necessary to power these modern applications. These data types can be structured, semi-structured, media data types, etc. But traditionally, we dealt with simple structured data, which was generally saved in traditional relational databases. So those databases had strict schemas that allowed you to only put in data of certain parameters into those databases. Then we started with working with more structured and semi-structured data. So semi-structured data joined the mix, and a lot of that semi-structured data started being saved on the cloud. So we had a paradigm shift from local relational databases to cloud databases. And now that we're moving into generative AI, we're utilizing multimodal data, as I mentioned before. So different types of data, images, audio, video, etc. And to get that information and have it searchable and be able to be used by applications, it has to be stored in a vector database, because that type of data not only needs the actual data set itself, but it needs the semantics around that data set. We'll talk a little bit more about that later. All right, so what are vectors? A vector is a long list of numbers where each number represents a different dimension in the input data. So each number in that vector corresponds to a specific feature that's been represented. As humans, we live in a 3D world, so we're used to visualizing data at lower dimensions. So two-dimensional data, think of a rectangle on a piece of paper, for example. It's got length and width, so it's two-dimensional. Whereas something like a box has got length, width, and height, and that's three-dimensional. The point is, it's easy for humans to be able to conceptualize dimensions of 2 and 3D, but once we start getting into higher dimensions, it's harder for us to comprehend. And that's where machines come into play. So in the AI world, we generally have vectors with sometimes hundreds, sometimes thousands of dimensions. And as I mentioned before, each one of these dimensions tells a story about that data set. For example, in natural language processing, we have vectors that represent sometimes over 1,500 dimensions. And it's not really uncommon for media files to have even more dimensions. All right, let's talk about embedding versus generative AI models. So large languages models like ChatGPT generate text by predicting the next word in a sequence. For example, on this slide, we've got the phrase, "I'm never gonna." And you send that phrase to a generative model, what it does is predicts the extra words that belong to that phrase. So the generative model, based on the data that it's trained on, it says, well, the probability of the next group of words to this phrase is "give you up," which obviously comes from a song, an old song. On the other hand, embedding models embed that data. So you send an embedding model a phrase, "I'm never gonna." The embedded model takes that phrase and vectorizes it. So it turns that phrase into a vector. And the point is, it not only stores the data, but also stores the semantics. So it's the semantics around that particular phrase that allows it to be searched against similar phrases. Since we need to find similarities, let's talk about the best way of doing that. Once we have the data represented as vectors, we can perform similarity operations. The way we do that is that we input a query that's also converted to a vector, and then we find the distance between the query and the actual data set. And the way we generally do that is by using nearest neighbor functions. So the most accurate nearest neighbor function is called K nearest neighbor function. It's KNN for short. And basically what that does is it takes the input vector and it finds you the specific vectors within the database that match that input vector. The problem with that is it's very computationally intensive. So it doesn't really scale well. As you start to get a lot of vectors into your database, it starts to take a much longer time to find those nearest neighbors. So what we do in practice is we utilize approximate nearest neighbors. So with approximate nearest neighbor algorithms, they provide results much faster. So they're much quicker and they significantly reduce the computational load. So you may not necessarily get the specific vector that matches your input, but you'll get something that's very close. And the main point is it saves a lot of time. So approximate nearest neighbor algorithms are basically the industry standard used throughout the industry by vector databases like Pinecone. Another way we can search is by combining filters with vector similarities. So on the right-hand side, there's a little snippet, code snippet of how we would do that. As you can see in this particular example, we're passing in the vector, and then we're passing in a metadata filter to help you specify your search. This helps to make the search a lot faster and a lot more specific. Now I'm going to get into a little bit of the serverless architecture. And my co-host, Zach, is going to handle that.
Yep. Thanks, Rick. Hopefully everyone can hear me okay. And apologies, we're having an issue so that we know that the chat with everyone feature is currently broken. At any rate, let's talk about service architecture. The thing that's the most exciting about the service architecture, from my perspective as a developer, is it is cloud native. And what that means is that it has been designed from scratch, from the ground up, to run in cloud environments, right? AWS or GCP. And Azure, that's extremely powerful because that allows us to take advantage of native cloud autoscaling capabilities so that, the idea, as you may have heard before in other serverless architectures, is essentially that you pay for only what you're using. You don't need to worry about performing, intensive maintenance or having expertise and having an entire team with deep expertise in doing cloud maintenance and automation, et cetera, as your app actually scales beyond the needs of your initial deployment, right? The really wonderful thing about serverless is that you, as we're going to see when Rick does his demo, is that you can, call the API, which is as it's designed. You call the Pinecone API, you set up an index, and you start writing to the index. It's really that simple, and then everything just works under the hood. So what you have been, relieved of needing to worry about operationally as an engineer, as a team, as an organization, and as a stakeholder, then is all of the security patching, maintenance, networking issues, like all of that goes away because you are writing to and reading from an API that has been designed from the ground up to be delightful to work with. So the other types of, at a high level, we'll touch on a couple of other components that you'll probably hear people speak about. So there's scalable blob storage for persistence and reliability. There are freshness and caching layers that are designed to ensure that even though you're writing at scale, when you're reading and doing queries, that you're getting the latest data for your application. And then again, as I mentioned, like you're only paying for the reads and writes and the storage that you actually use. And so this decoupling of the storage and compute is really an enablement and a cost savings that we kind of return back to our customers. The other thing that's exciting is that if you've ever built any app that needs to handle multi-tenant data, so that's, you can imagine that you've got users in different organizations, or data might be private in some way, or in some way sensitive. You might want to ensure the separation. Pinecone has native first class namespaces built in. They're very easy to use. And so you get, hundreds of millions of namespaces, hundreds of billions of vectors. Again, everything has been designed to scale infinitely and to return queries in milliseconds. Thanks. Do you want to advance to the next slide, please, Rick?
Sure.
Okay. Up next is this is slightly different from just pure vector database. If you may have heard of us before, but this is very exciting. So you may have heard recently that we've announced Pinecone Assistant, and this is in public beta. This is a managed service, and the idea, in which I believe we have a short video demo that we're going to show in a second. But you can log into the Pinecone dashboard. You can drag and drop your PDFs. For example, I used some financial 10Ks. You could use, giant medical documents or case law, and then Pinecone Assistant will instantaneously, perform, semantic chunking, embedding, and upserting in the background for you, so that you don't need to do any additional work. And then you can send queries to that assistant for a end-to-end best practices baked in retrieval augmented generation pipeline. So this is an extremely expedient way to get up and running with a chatbot that's informed on your proprietary or private context, and then a very fast way to enable additional capabilities in your own organization or team. And so you also get full control over your data. So we're going to take a look. I think in the next slide we've got a quick demo that we can play here, and I can talk through it as we do that. Awesome. So what you're going to see here is the user is logging in. They've logged into the Pinecone dashboard. They're going to just quickly give their new assistant a name. And the next step is they just drag and drop files that they have locally. These are PDFs. They're 10K financial reports from that are looking at the company health and growth and spending and challenges and all that stuff for NVIDIA and AMD, just as a sample. And then just as quickly, you're able to type in a question saying, what can you tell me about AMD and NVIDIA's earnings in 2024? And you can see that that's how quickly, we start streaming results back from the assistant. And you can also notice, if you have a keen eye, that there are citations that are automatically baked in there. And so you're not just getting retrieval augmented generation, you're getting retrieval augmented generation with citations, right? So we're having an LLM answer your questions, your queries, using your private proprietary context and grounding the answers in whatever ground truth you have provided. And this will also reduce the overall likelihood of hallucination, and it just increases the likelihood that your end users have an excellent experience. And by the way, the UI that you're seeing here in this app is what we call a sample app, and that is fully live and available on Pinecone. It's open source, and we make it really, really easy for you to quickly clone that and get up and running with the exact same experience. So feel free to ask any questions about that. Happy to talk more about that. Thanks. And then let's step into, so these are some of the main use cases currently. These are not an exhaustive list of what you could use Pinecone's vector database for or what it excels at, but these are some of the top use cases that we're finding today with our customers. And so, we're sharing these, like, think of them as essentially in three different buckets. The first is multi-tenant RAG, right? So not just retrieval augmented generation, but how do you perform retrieval augmented generation when you need to have guarantees, strong guarantees, and logical separations between all of your various organizational or customer data, right? So as we just saw, one application of that is the Pinecone Assistant, but we also have Notion, Shortwave, Cisco are doing retrieval augmented generation at scale using Pinecone. The other is AI search or vector search. So anyone that's providing an excellent search experience on top of a large proprietary data set. Lexical systems eventually hit certain performance limits, but the outcomes here are a better user experience, faster time to value. Really what we're talking about is, if you've seen any of the latest demos, from the last year and a half of generative AI applications, that aha moment when the application really seems to actually understand and get it, that's the experience that we can provide with vector search, which is extremely performant as well. And the third is classification and labeling. So we also refer to that kind of internally as vector augmented learning. But the idea here is that it increases accuracy. You can build a moat around your actual IP and your data. And so we're also seeing customers have success with this use case as well. Thanks. Next slide, please. And then so now we're going to jump into the demo. So I will pass it back to Rick.
All right, great. Now for the fun stuff. All right. So as I mentioned before, this demo is going to be about Pinecone 101. So it's kind of an introduction to Pinecone and how simple it is to use. Here you can see in a flow diagram, we're going to go through some of the things we'll be actually doing in this demo. We'll get some vectorized data. We'll ingest that data into an index, and then we're going to obviously store it in Pinecone, which is a cloud native environment. Then we'll also issue a query. We'll have to embed the query and then do a search and retrieve the results. All right, so let's just walk through this notebook. Here we're loading the libraries. And this is a live demo. So I'm sitting in Florida. So, there's some network lags that we have to deal with. So here we're going through and installing necessary libraries. Now I'm going to authenticate, get a Pinecone key. Now let's create an index. So we're creating that index in US East on AWS, checking to see if that index already exists. All right, and now let's get some data. I'm going to talk about this data set more a little bit later, but basically it's some doctor's notes that we are using to show how these queries work. All right, so we're loading the data. This data has already been vectorized. Here you can see what the vectors look like, and then that's a little example of the metadata. And now we're going to upload that data as a data frame. Pretty fast. And now I'm going to set up an embedding function. So as I mentioned before, the data we just uploaded was already embedded. But now I want to search that data. So in order to do that, I have to embed the query. And here's where we embed the query. So that's the embedding function. And now we're going to embed the query, which is, what if my patient has knee pain? So again, this is doctor's notes. So that question is relevant to that data set. And now we're going to get the results for our question. All right, so we wanted the top 3 values based on that question, and that's what we got. We've got an ID of 28, which says metadata, condition, knee pain, orthopedics, and it's a referral, which matches quite well with the input vector that we wanted to search for, input query that we wanted to search for. So that's the highest ranking result we got. We're using a cosine algorithm to create the nearest neighbor. That's why it's in decimal places. Now, what we can also do that I spoke about through the presentation was we can also filter by metadata. So the snippet that I showed in the presentation was filtering by vector and metadata. In this example, I'm filtering by the ID and metadata. So what I did is I chose the ID for the best match and then the metadata, and now I'm doing a search on that. The good thing about being able to use metadata and vector ID filtering is you get very, very precise results. And they also pretty performant. So they're faster than generally having to search through the full cluster. All right, now let's get the results back for our query. And then let's look at them. So as expected, the result score is 100%. Well, 1, because it's cosine. And it's because, again, we specified the ID and we specified the metadata. So we had basically a perfect match. I'm going to go ahead and clean all that up. And what I also wanted to show was the Git project that comes along with this webinar. So this webinar also will provide you with a Git project. The Git project has the notebook that we just went through. And basically all you have to do to use this Git project is modify the config file. So here I'm using an example of the config file because I don't want to show you guys my keys. But all you would have to do if you actually access this project is go into this config file and add your own keys. here is a data set that we're using. This is before embedding. And what I'm going to do now is go ahead and embed that data using an OpenAI model. So we're going to do basically the same steps we did within the notebook, but we're going to use an API from OpenAPI. I'm sorry, a model from OpenAPI. I'd also like to mention that within the notebook, we utilize a model that is available by us. So to embed our input query, we used a Pinecone embedding model. In that example, I should have specified it there. But we use a Pinecone embedding model. And now I'm just showing how to do a similar thing, but using an OpenAI embedding model. So I'm going to run this. This will take a minute because what this is doing is accessing these doctor notes and then embedding the notes. So it's embedding the data within these doctor notes using an OpenAI embedding model, as opposed to the notebook, which used a Pinecone embedding model. So that's running. Again, has to go through my network and go to OpenAI, utilize their model, and then spit back out the vectors. Should be done in a minute or two. Once that's completed, the next thing we'll do is perform the search like we did from the notebook. But again, utilizing an OpenAI model this time. All right, so should be done anytime now. By the way, while we're waiting for this, that's actually the reason why in the notebook I use an already embedded data set, because I didn't want to have to go through this wait. Anyway, it's back now, and here is the output. So this is what that data looks like when it's vectorized. Obviously, you can see it can take up a lot of space, and the fact that Pinecone is able to separate compute from storage means that you can minimize the cost that's you're going to have to pay for storing this data set. So as I mentioned before, these embedded data sets can be very large. So you want to separate compute and storage because you don't want to have to increase your node size as you increase the number of data vectors that you add to your index. All right, so now let's go ahead and search that data set. So now I'm going to perform basically the same search I performed before. What if my patient has knee pain? But this time using an OpenAI model on an OpenAI embedded data set. All right, we should see very similar results. Yes, the results are similar. Scores seem to be a little around the same. But the bottom line is what I wanted to demonstrate is how easy it is to utilize Pinecone to perform these actions. So again, in the notebook, we just uploaded an already embedded model. We use the Pinecone embedding model to search that. And then here from code, we created data set that was embedded by the OpenAI model. And then we did the search based on that OpenAI model. Again, in the project that will be provided, we've got code to do these actions. And then we also have code that utilizes a Hugging Face model. So we have code to utilize the Pinecone embedding model. We have code to utilize the OpenAI embedding model. And then we have code to also utilize a Hugging Face model. And that's about it in terms of the demo. So I'll turn it over for some question and answer now.
Awesome. All right, thanks, Rick. So we got a couple of good questions. So first, Anil, hope I'm pronouncing that correctly, asked, how does indexing help me with my vector database, or just trying to get a sense of what is the purpose of an index in a vector database? And then also, I think a little bit about like questions around, best practices when you're dealing with Pinecone. Let's start just with, what is the index actually doing in a vector database? So in a vector database, the index is really what's allowing for the efficient search and retrieval of the similar vectors, right? And so that's part of like clustering the vectors that are most closely related together into clusters or neighborhoods, if you will, and then enabling that nearest neighbor search that Rick was explaining earlier on in the talk. So it's really about doing that, and then advanced indexes like the one that Pinecone uses, which is custom, can enable other features down the road and even high performance characteristics. But the long and short of it is about enabling efficient search, quick retrieval, and then scalability and doing query performance optimization, similar to the role that indexes play in other traditional databases. Um, the other thing that I'll share though is that we do have a guide, and I linked it in the chat, about building with Pinecone when you're doing anything that has to do with multi-tenancy. And so you can find some best practices there. In general, if you've got, let's say that you're dealing with, you've got three different types of data. You can imagine you have text data, image data, video data. You can get away with using a single index and putting those in three separate namespaces. So you could imagine that you have a video embeddings namespace, an image embeddings namespace, a text embeddings namespace. All of these things at the end of the day, whether they're the indexes, they're namespaces, projects, right, which are the superset above indexes themselves, are really tools, and they're organizational tools that are there to help you kind of do what you need to do, and to arrange your application and your data flow and pipelines the way that your organization needs them to run. So that's kind of the long answer there, but the guide that I linked and dropped in our group chat is excellent to review and check out. There was another question, which is, what are some best practices, use cases for choosing the right distance metrics? This is another excellent question. Like all good engineering questions, the answer is, it really depends on what you're doing, like your workloads, your requirements. We have a guide for that as well. I linked it in the answer, but I'm also going to drop it into our group chat now. And as it says in, this guide, the rule of thumb is essentially to use the same distance metric that your embedding model that you're using in your pipeline or in your application was used, used in order. So if that's, cosine, stick with cosine when you're setting up your Pinecone index, essentially. So far, those are the only open questions that I saw. I don't know if we've got others, or it doesn't look like anyone's been able to chat. So maybe we'll stick around for another little bit and see if anyone wants to open another question. But I think those are the two that we got so far. Do those answers make sense, Rick, or did I miss anything important there?
Answers made sense to me. I think
Okay,
since we have a few minutes, maybe we can talk about Pinecone Assistant a little bit more.
sure. Yeah, one thing we can share maybe is, I can actually, let me go get you the link real quick, Rick, and we can share with people the sample app there. So for all the hackers or developers on the call, this is something that we've built so that it's really easy for you to get started with building that exact same kind of demo experience that we just shared in the video. But I will put this in the chat as well. So this will link to, the public demo, so you can play with the Pinecone Assistant, the same app and UI that we showed today. But more importantly, if you look at the top of that page, there's the one npx command. It's a one-line command. And if you have npx, which is the JavaScript or Node package manager tool installed, then this will run and it will clone the public code repo for this experience. And it'll even help you set up the environment variables, the secrets like your Pinecone API key that you need. And so we've built this intentionally to be the quickest on-ramp possible for getting up and running with Pinecone Assistant if you need to host the UI and the chat UI somewhere, either publicly or privately, right? But anybody can go now and build, anyone that's on the public beta can build the assistant as we showed in the demo and add their documents and start chatting with it immediately. All right, looks like we got a couple new questions. What are your recommendations for evaluation tools? So let me start with this one because we've actually got a good answer here. So a couple months ago, we wrote a ebook called Vector Databases in Production for Busy Engineers. And Mohammed, I'm going to drop the link to that right now in our group chat. And so this is the RAG evaluation chapter. And if you go through that, it shares kind of like a top level view of what are the main metrics that we tend to use in retrieval pipelines to demonstrate performance essentially. and then it explains how they're calculated and the formulas, and then it gets into some of the open source options, tools, and then even paid services that you can use today to do evaluation on your retrieval augmented generation pipelines, or just in general your retrieval pipelines. So hope that helps there. And then another question is, let's say I have a data set with a product name, product description, company description. I'd like to index both product description and company description so that I can find the right company or product based on the search query. How would I index the descriptions? One index for product description and one for company description, or would I put them in one index? That's a great question, Satish. That is actually why metadata is so powerful, because, and I'll find the link to our kind of metadata quick start guide. You can put them both in one index, and then you can set that both the company description and the product description as metadata fields. And then you can do what we call metadata filtering to do any query you want and filter on that. And even in one of the first slides that Rick showed today, he had a filter in there. And so that shows that, once you've set your metadata, which again, think of it like an arbitrary JavaScript object. It can really be an object with any field and values. Once you've set those values, you can use metadata filtering to actually query on them to get the right results for whichever company or product you're looking for. So great question. Another question real quick from Mohammed. Another question is, any recommendations around the best chunking techniques? Yes, we have a Pinecone chunking guide. Let me grab you that. So this is called Chunking Strategies for LLM Applications. I'm going to drop this here. This is also going in the public chat. But the other thing I'll say, Mohammed, anytime. The other thing I'll say is, if you're comfortable with LangChain for either Python or JavaScript, the recursive character text splitter, which is one of the examples that they show in most of their docs, is pretty good, and it's going to do what you need for like 85% of use cases essentially. So that's also a quick way to just get, if you're dealing with text, then you can start with that and see if the recursive character text splitter gets you the accuracy that you need or not. The other question is from Ross: with markdown data and longer text embeddings, what are your recommendations for chunking? Similar to what I just said to Mohammed, but in LangChain, for instance, and probably other frameworks, there are markdown specific file loaders. And what those will help you do, if you look for them in the LangChain docs, is import just the raw data without pulling in syntax that you don't necessarily need, like cleaning markdown data, essentially sanitizing it for you. And so that seems to work pretty well. I do a lot of chunking of MDX files, which are files that are mostly markdown but can include JavaScript components. So that works decently well for that. In general, my recommendation is use a custom file loader for the type that you're dealing with, and then if you have too much trouble with that, or if it doesn't work exactly to your specifications, give an LLM IDE such as Cursor a try and try to have it build a quick one for you. Maybe use that. Anil asked, is it possible to host a Pinecone vector database in your own AWS environment? Not at the moment. So it's still, as of today, fully managed as a service. So you have to connect up to the API. That could possibly change in the future, but that's not a product commitment by any stretch of the imagination. And there may also be things on the horizon that would help test in a different kind of paradigm, if you can imagine. But the answer, at least today, is that it has to be deployed in one of our environments. Okay, great questions, everybody. Really appreciate it. Did I miss any link that I owed somebody? I think I gave them all. Any other questions that for Rick or myself? The other thing I'll share is there's also the Pinecone community forum. So if you're not aware of that, you can go to community.pinecone.io and ask any questions you have there. And myself and a bunch of other engineers and Rick are in there as well. And so we will do our best to answer any question you might have there too. So even if you leave this call and then remember that you had a question, then you can ask us that way. And how can we create API keys related to projects? So that actually happens automatically, Abhinav. When you are signed into your Pinecone account, you're automatically always on one project. You can select and pick which project in the left rail you want to change to. but when you create an API key, it's automatically associated with whichever project you are currently in when you created that API key. Okay, here's a great question. Anonymous attendee. What are the reasons for not using Pinecone Assistant and using custom code for RAG? Everything in engineering is a trade-off. And so the reasons that I would not want to use Pinecone Assistant and do custom code for RAG is if I had some extremely bleeding edge or very abnormal workflows, or I wanted total control over every single step in the process down to parsing file types, chunking strategies, the overlay and the offset of my chunking strategy, the number of characters, the tokenizer that I use, the database type that I use, like the partition in native. Like if you wanted control over everything, then you build the pipeline yourself. And I've built, RAG pipelines that do that. If you're trying to get up to speed very, very quickly with best practices baked in already, then Pinecone Assistant is an excellent choice for you. And we are hard at work trying to make it even faster and easier to get once you've done the drag and drop of your documents and maybe set a prompt, then to get the public facing version of that agent or assistant visible very easily, even if you're not a developer, or private, even if you're not a developer. So that look for that possibly in the future as well. But that's a great question. In the TLDR to that question is that if you want more control or if you need some insane level of customization, build the entire pipeline yourself. Also, if you are wanting to learn how to build a RAG pipeline end to end, build the pipeline yourself. If you're trying to get up to speed super quickly with a best practices retrieval augmented generation pipeline that works and that has, like top tier chunking strategies and that is performant and fast, then use Pinecone Assistant. Okay. When will Pinecone be available in the AWS region EU Central 1? I don't know, Anil, so I'm not going to say personally, but we do have a page somewhere if you Google for Pinecone and then regions where we keep the list of the updated regions, and we do go back and update that as we go. So I'm sorry, it's not an actual roadmap promise, but I know that that's being looked at regularly. All right. So far, I think that's everyone. Did we miss any chat questions?
It looks like you got them all.
Cool. Yeah, thank you all for attending and joining, and thank you for all the excellent questions and participation. We really appreciate it. And if you have feedback too, either here or in the forums or wherever about how we can make this better, just let us know.
All right, and the follow-up email will include some of those links that Jack mentioned. It will also include a link to the repo that's, currently on the screen.
Awesome.
Thanks a lot, everyone.
All right. Thanks so much, everyone.